Okay, so evaluate the definite integral from 1 to 2 of t squared plus 1 dt using the fundamental theorem of calculus. So I have to find an antiderivative of t squared plus 1. It's t cubed over 3. That's an antiderivative of t squared, right? Using the power rule for antiderivatives. An antiderivative of 1 is t. You know, you might be tempted to say x, but my variable here is t. And I have to evaluate that at the endpoints. So my answer is just 2 cubed over 3 plus 2 minus 1 cubed over 3 plus 2. These parentheses are really important. If you don't use them, you might miss your sign. So I get 8 over 3 plus 2 minus 1 over 3 plus 2 in parentheses. So I have 8 over 3 plus 2 minus 1 over 3 minus 2. The 2's add to 0, so I get 9 over 3 or 3. What does that tell me? That tells me, if I look at the graph of t squared plus 1 on the interval from 1 to 2, this area is 3 square units. Remember, a definite integral gives me net area, the area above the horizontal axis minus the area below. But there's more area, all the areas above, so it's just area. Okay. Remember, fundamental theorem of calculus, I can use any antiderivative. I don't have to use the most general, so I don't have to put the plus c. Common mistake is for people to put a plus c down here. I mean, that's crazy. That doesn't make sense. What's the area under this curve? Y equal x squared plus 1 on the interval 1 to 2. It's 3. It's not 3 plus c. Now, I could put the plus c up here and then the plus c here, but what I would have would then be c minus c, or that's 0. Okay. Do this next one. The integral from 1 to 3 of t squared plus 1 over t dt. Now there's some algebra you'll want to do first before you start your anti-differentiating rules. I'll give you a minute to try to figure out that algebra, so work on this, please. The algebra is t squared over t plus 1 over t Remember, we did an indefinite integral like this a few days ago. Now we're just doing definite integrals. So I do the anti-differentiation. Because of fundamental theorem of calculus, I do the same anti-differentiation I always did. Now I just plug in the endpoints. Antiderivative of t is t squared over 2. Antiderivative of 1 over t is natural log absolute value of t. I have to evaluate that from 1 to 3. So it's 9 over 2 plus natural log 3 minus 1/2 plus natural log of 1. Just input the top number, input the bottom number, subtract. So that's 9 over 2 plus natural log 3 minus 1 over 2 plus 0. The natural log 1 is 0. So I get 9 over 2 minus 1 over 2. That's 8 over 2, or 4, plus natural log 3. That is the area, the net area between the graph of y equal t squared plus 1 over t on the interval from 1 to 3, the net area between the graph and the x-axis. Turns out our function's always positive on that interval, so net area is actual area. Okay, take a minute and do this next one, the definite integral from -2 to 0, x plus 1 times x minus 1 dx. Again, think about how to find an antiderivative of x plus 1 times x minus 1. Don't wait me out on this one. Please be working on this one. First, you have to do some algebra. Multiply x plus 1 times x minus 1 by 4. You get x squared minus 1. Are you writing your dx's every time? That's so important, because when we have u sub problems, which will be in our next lesson, if you're not writing that dx, that will really mess you up with the u sub. It's just really important. An antiderivative of x squared is x cubed over 3. An antiderivative of 1 is x, a independent variable's x, and evaluate that from -2 to 0. Make sure you agree with those parentheses. If you looked at the graph of f of x equals x plus 1 times x minus 1 on the interval -2 to 0, you would notice that it looks like there's more area above the x-axis under that graph than below the x-axis under that graph. How much more area? 2/3 of a square unit. Okay, do the next one, and be careful with the SIGNS. Remember, derivative of sine x is what? Cosine x. Antiderivative of cosine x is sine x. Derivative of cosine x is negative sine. So what's the antiderivative of sine x? It's negative cosine, isn't it? Let's do a little check. What's the derivative with respect to x of negative cosine x? On an antiderivative, you can know if you're right or wrong. You don't have to guess. You can know if you're right or wrong. Just take the derivative of what you think's the antiderivative. It would have to agree with the original integrand. If I think the answer to an antiderivative of sine is negative cosine, take the derivative of negative cosine. The negative comes out front. Now the derivative of cosine is negative sine. So hey, I do get sine x, which is this integrand. So I'm correct. So substitute pi for the variable. Substitute pi over 2 for the variable. Subtract. So I get negative cosine pi minus a minus, that's a plus. Cosine pi over 2. Remember, if you're doing this on your calculator, make sure you're in radian mode. It's easier to do it in your head on the unit circle. But however you do it, you get an answer of 1. If you look at the graph of sine x from pi over 2 to pi, it looks like this. This is the graph of sine x from 0 to pi, but from pi over 2 to pi, here's the graph. And there's one square unit of area right here that's shaded. Okay, think about how you would do the last one. The definite integral from 0 to 4 of x square root of x. You need to do some algebra first. That's x to the first, x to the 1/2. So that's just x to the 3/2. Now, go from there. Antiderivative of x to the 3/2 is x to the 5/2 over 5/2. I evaluate from 0 to 4. To divide by 5/2 is to multiply by 2/5. This 2/5 can either go inside the brackets or outside. I happen to factor it out. So you get 2/5 times 4 to the 5/2 minus 0 to the 5/2. 4 to the 5/2 is just the square root of 4, which is 2, then to the 5th power. So that's 32. So I get 64 over 5. There's that many square units of area underneath the graph of y equal x times square root of x on the interval 0 to 4. Okay, you've got web assigned homework on this assignment. It's a bunch of problems where you just, similar to what we've just done, you use fundamental theorem of calculus. You can practice your anti-differentiation this way. I didn't put any u sub problems. We'll take up doing definite integrals that involve u sub in the next lesson. There is an initial problem about realizing that the distance traveled is the area under a velocity curve.